Today we're going to talk about formal charge. Now sometimes we can draw more than one Lewis structure for the same molecule and still follow the octet rule. Here are some examples where we have carbon dioxide. Now there are 3 ways that we could draw this molecule. So how do we know what the most reasonable Lewis structure is when we have multiple possible Lewis structures? It could be this one, or this one, or this one. Well, the way we figure this out is by calculating the formal charge. Now let's talk about what this is. What's formal charge? Well, it's essentially a bookkeeping mechanism for keeping track of electrons. A formal charge is defined as the charge that an atom in a covalent bond would have if the bonding electrons were shared equally. Now, we know they aren't really shared equally, especially when bonds are polar, but we will pretend that they are. Now, since this is all related to hypothetical stuff, it's not so important to remember what these things are, but you have to know how to use formal charge. We use formal charges to determine which of several possible structures is the most likely. Here's how it works. When we assign formal charges, we assign a separate formal charge to each atom in the molecule. And we're going to use this equation right here. The formal charge is the valence electrons minus the number of lone pair electrons minus half the number of the bonding electrons. And we can write this out as an equation that looks like this. It's going to make more sense when we use this in a moment. Now, for an electronically neutral molecule, the sum of the formal charges of the individual atoms must be 0. This means the formal charges are going to add up to 0 because this is neutral. This is going to be different when we're talking about ions, where the formal charge is going to be the charge on the ion. For example, say you have a molecule with a net charge of -1. The sum of all the formal charges of its atoms are going to add up to -1. Now, checking what your formal charges add up to is going to be a good way to double check and to make sure that you have assigned your formal charges correctly. Okay, let's look at an example. Here we have the cyanide anion, and we're going to use our formula to calculate formal charges. The first one we're going to look at is the carbon. Remember, we do this on each of our atoms. So if we remember what the valence is on carbon, that's going to be 4. We're now going to subtract the number of lone pair electrons, and we see we have 2 of them. So let's subtract 2. Now we're going to subtract half the number of the electrons in the bonds, the bonding electrons. We have a triple bond here. Each of these bonds has 2 electrons in it, and that means we have 6 bonding electrons here. And what we're going to do is we're going to take half of those, which is going to give us 3. So we have 4 minus 2 minus 3, and this is going to give us a total formal charge of -1. And let's go ahead and put this right over our carbon atom. Now let's take a look at the nitrogen. We're going to use the same formula. Now, if you remember, nitrogen has 5 valence electrons, and we can see from this structure that 2 of these electrons are in a lone pair, so we're going to subtract each lone pair electron. And just like we figured out with carbon, we have a triple bond here. Each bond has 2 electrons in it, so that means we have 6 electrons that are tied up in the bonds. We're going to subtract half of these. 1/2 times 6 is 3. So we've got 5 minus 2, minus 3, and this gives us a formal charge of 0. And we're going to put this over the nitrogen. The way we're going to check this is we're going to remember that when you have an ion, the formal charges must add up to the charge on that ion, which in this case is going to be a -1. And when we check this, we find out that it does. Now, if this were a neutral atom, we would expect the formal charges to add up to 0. If this were a +3 cation, we would expect our formal charges to add up to +3. Why do we do formal charges? Well, it turns out that formal charges are helpful if we are trying to decide between possible Lewis structures. We want to choose the Lewis structure that is the most stable. The most stable structures are the ones where the absolute values of the formal charges are closest to 0. Now let's do an example. Let's look at thiocyanate. Now, if we put together the Lewis structures on this, we would find out that we have 3 possible structures. One of them has sulfur in the middle, one has carbon, and one has nitrogen. Well, how do we choose between them? The answer is going to be to look at the formal charges. And when we do this, we are going to look at the formal charges on each atom in each possible structure. So let's take a look at structure A, our first structure. And we're going to use our formula. Formal charge equals the valence electrons minus the number of lone pair electrons minus half the number of electrons in bonds. When we look at nitrogen, we find that nitrogen has 5 valence electrons. We see that 4 of them are in lone pairs. And then we have an additional 4 tied up in that double bond. We're going to take half of that. When we add all of these together, we get a formal charge of -1. We'll put that right there. Now let's look at the carbon atom. And we know that carbon has 4 valence electrons. We see that we have 4 electrons that are lone pair, and we have 4 electrons that are tied up in that double bond, and we're going to take half that number. And when we add all of these together, we're going to get -2. And we'll put that -2 next to the carbon. Now let's take a look at sulfur. We know that sulfur has 6 valence electrons. And if you can't remember that, just look it up in the periodic table. We see that we have no lone pair electrons, but we have 8 electrons that are tied up in those double bonds, and we're going to subtract half times the 8, and this is going to give us a formal charge of +2. Okay, so those are our formal charges on this particular structure. When we check this and add them all up, we see that our total is -1, and that is the charge on the anion. So this all checks out. We're good here. Let's go on to structure B, and we'll take a look at the nitrogen first. Well, nitrogen has 5 valence electrons. We see we have 4 lone pair electrons, and we have 4 electrons tied up in that double bond. We're going to take half of that, add them all up, we get -1. And we'll put that -1 right under the nitrogen. Let's take a look at the carbon. We have 4 valence electrons. We do not have any lone pairs, so we subtract 0. We have 8 electrons that are tied up in those bonds, and we add these all together, we get 0. We'll put that right under the C. Now let's look at the sulfur. Sulfur has 6 valence electrons. We subtract 4 lone pair electrons, and we subtract 1/2 of the 4 electrons that are tied up in that double bond, and we get 0, and we'll put that under the sulfur. We're going to check the total charge by adding up all the formal charges. We get -1. That is the charge on this ion. This is what we want to see. Okay, now let's do structure C. We're going to look at nitrogen first. Nitrogen has 5 valence electrons. It does not have any lone pairs, but we have 8 electrons tied up in those bonds, we're going to take half of those. That'll be 4. Add them all up, we get +1. We'll put the +1 under the nitrogen. Now let's look at the carbon. Carbon has 4 valence electrons. It has 4 lone pair electrons. Let's subtract those. And we see we have 4 electrons tied up in those bonds. We're going to take half of those. Add it all up, we get -2. We'll put the -2 under the C. Lastly, we're going to look at the sulfur. Sulfur has 6 valence electrons. We can see that we have 4 lone pair electrons, and we have 4 electrons tied up in those bonds. We're going to take half of that, leave us 2, add them all together, and we get 0. We'll put that under the sulfur. And let's double check, and we see that if we add our formal charges, we get -1, which is the charge on the anion, and this is what we want. Now that we have our formal charges, we have to figure out which structure is the most stable. And the way we're going to do this is we're going to look for the structure that has the lowest overall formal charges. So think of it as the lowest absolute value of these, and it's going to be the center one because it has a -1, a 0, and a 0. And we can see that the other two have +1s and -2s, and that's a lot of non-zero formal charges on structures A and C. Okay, so here are 2 other possible structures. They're more complicated. We need to find out which one is more stable. If we look at the one on the left, we have a lot of +1s, we have a lot of -1s. All 5 atoms in this ion have formal charges that are not 0. Let's look at the one on the right. We see that 2 of our formal charges are 0, and the other 3 are -1. Clearly the one on the right is the one that's going to be the most stable because the overall formal charges are lower than the one on the left. So what happens if we have 2 valid Lewis structures with similar formal charges? Well, the more stable structure will be the one with the negative formal charge on the more electronegative atom. Let's take a look at this. Here we have dinitrogen monoxide, and we have 3 possible structures. If we take a look at these structures, we can immediately see that structure 3 has a lot of formal charges. Each atom in this molecule has a formal charge with absolute value of 1 or 2. These are far from 0. This is not optimal. But if we look at structures 1 and 2, their formal charges are practically identical, but they're on different atoms. One of these 2 is going to be the most likely one. Now, in order to figure out which one's more stable, we have to ask ourselves which of these structures has the negative formal charge on the most electronegative atom. And if we take a close look at this, we're going to see that structure number 1 put a -1 charge on oxygen, which is more electronegative than nitrogen. So this is going to be the most likely structure. An important thing to remember is that formal charges aren't real charges. They're just a bookkeeping convention that can help us arrange Lewis diagrams in order of importance. So let's summarize. Sometimes we can draw more than one Lewis structure for the same molecule and still follow the octet rule. When we do this, we can use formal charge to determine which structure is the most stable and the most likely. And we have a formula. Formal charge equals the valence electrons minus the lone pairs minus 1/2 of the bonding electrons. The structure that has formal charges that are closest to 0 is going to be the most likely structure. So in this case, structure B is going to be the most likely. If there's a tie, the structure that has the negative formal charge on the most electronegative atom is the most likely structure. In this particular case, we have a -1 on the oxygen atom in structure 1, so that's our most likely structure.